I need help. I don't get this. It's too hard. Oh my goodness, teacher.
Hello, struggling students. My name is Quinn, and I'm here to teach you all about inscribed angles. Woo, geometry! Alright, let's start. An inscribed angle is the angle formed by two chords that have a common endpoint. Let's remember that this is a common endpoint, and let's remember that chords are a segment whose endpoints lie on the circle. Continuing on from our previous lesson, we're going to talk about the relationship of the inscribed angle to the intersected arc. Remember that an arc is a piece of the circumference of a circle. The intersected arc is the arc that lies between the interior endpoints of the inscribed angle. The measure of the intersected arc is congruent to the measure of the central angle, which is the point that lies in the exact center of the circle. And the measure of the inscribed angle is half the measure of the central angle. This relationship between the inscribed angle and the central angle is called the measure of an inscribed angle theorem. So remember that if the measure of the inscribed angle is half the measure of the central angle, that means that it's also half the measure of the intersected arc. Alright, young students, now let's look at some examples. If the measure of the intersected arc is 90, let's find the missing parts with the information that we have. So if it's 90, how do we find the central angle?
The answer is 90.
Great job, young Padawan. Now that we have found the measure of the central angle using the measure of the intersected arc, can you tell me what the measure of the inscribed angle is?
The answer is 45.
Great job, young Padawan. So, we're going to do a second example just to reinforce your learning. This time we're going to work backwards. And using your knowledge, we already have the inscribed angle. So, using your knowledge of the measure of the inscribed angle theorem, what can you tell me about how to find the central angle?
The answer is 100.
That's right, young bull. You got it correct again. Proud of you. Because using your knowledge of the measure of the inscribed angle theorem, you were able to conclude that since the inscribed angle is 50 degrees, and you would have to double that to get the central angle, because this is half of the measure of the central angle, so this would be 100 degrees. And since this is 100 degrees, it's congruent to the intersected arc, so this would also be 100 degrees.
I don't want to do this. I just want to hang out with my friends. This is pointless.
Don't frown, kid. There's inscribed angles everywhere you look. You just gotta look carefully. And there's inscribed angles even in your games. Sounds silly, but here's some evidence. If you look at this pool table, alright, say the ball starts here at this corner. And it goes up in this direction, bounces off this wall, and goes back down the other direction. Notice how it forms two chords, because there's segments that have a common endpoint. And since they share an endpoint, that would create the inscribed angle.
I guess you're right. There are inscribed angles everywhere I look, even in games. This is crazy. Thank you.
I told you you could do it. Great job, Squirt.